Okay, piggybacking off of the last video, a few more examples here. Notice the second and third have natural log in them. So first let's begin with the one without natural log. We had looked at some examples with e to the x, right? And I had said let dv be e to the x. Just a good rule of thumb. Well, this one doesn't have it, so now what? Second good rule of thumb, so first dv, let it be some form of eu, right? E to the x. It's one good thing to keep in mind. Another thing is let your u be the simple part. And honestly, in the last video, u was always the x or x squared, whatever it was, right? The more simple part. We want an easy derivative. That's the mindset we're going to do here. So u, easy part, is just x, okay? And du is just 1, right? dx. So dv then, we have this square root of x plus 1, but it's in the denominator, so we could think of that as x plus 1 to the negative 1/2. That's ugly, but it is what it is. So the integral of dv, right, because here we're doing derivative, here we're doing integral. So we almost have, we do have a form of u substitution here, but we're lucky because u turns out to be just 1, right? Because if I'm integrating, let's do this off to the side because it's worth taking a look at. If I want to integrate x plus 1 to the negative 1/2, told you I forget that dx, then I'm using u substitution because u is x plus 1, du is just dx. So therefore I would have, switch colors here, this becomes u to the negative 1/2, here's du, okay, and the integral of that is u to the positive 1/2 divided by 1/2 or times 2. Now we have plus c, but again, don't worry about that till the end because we're going to have another integral. So u, though, remember, is x plus 1. So therefore, the integral of this guy here becomes 2x plus 1 to the 1/2. Alrighty. Now, like I said, if you're not using substitution, we got lucky here. And the reason we got lucky is the derivative of that came out to be 1. So if you simply integrated from this step, right, I'd add 1, that'd be 1/2, and then divide by 1/2, which is times 2. But you do have to keep in mind chain rule or reverse chain rule. Use substitution. Okay, moving forward. I wrote the formula again over here, uv minus v du. So uv, x times 2x plus 1 to the 1/2 minus integral v du. So 2x plus 1 to the 1/2. Du is just dx. Okay, great. First part, again, really not much we could do. X plus 1 to the 1/2 or square root. In this next one, again, we have u substitution, kind of like we did here. But we could see du is just 1 again. Right, so let's go ahead and just integrate this in our head. Minus, now we do have this 2, x plus 1, so add 1. It becomes x plus 1 to the 3/2 divided by 3/2 or times by 2/3 plus c. All right, and that's it. We have this, minus 4/3 we can do, 2x. And, kind of up to you. I don't really know. We started with a square root. It'd probably be best to go back to square roots. But the problem is this one is the 3/2 anyways. So what does that mean? X plus 1 to the square root cubed plus c. Okay, that is an ugly answer no matter how you look at it. All right, moving on. Integral of ln x. At the beginning of the year, you verified the result here, and some books treat this more as a formula, but the reason the formula works is because it's integration by parts. And, well, now it's like, I don't know, what do we do with this thing? Right, we have dv over here. We don't have any e's. U is the simple part. I don't know, like, what is the simple part? It's kind of weird. So the last thing is, if you have ln's, usually you're going to make u the ln. Why? Because we can do the derivative of ln. I don't know the integral, right? That's the whole problem. So if I did like u is dx, if I made that u, fine, derivative is 0, that's weird. But then if I called this dv and I had to integrate, I'm right back to the original problem. And I would take away my u. So all in all, it's just kind of a weird thing. I don't know. So it's almost a trick, you know, someone discovered it, it works, let's do it. This is u, and by default, the only thing left is this, so that's dv. Okay, so off to the side, u ln x, dv is just dx. The derivative of u, the derivative of ln x, is 1 over x. The integral of dx, right, I'm integrating, just becomes x. Right, the integral of some constant, technically we have a 1. A constant, it becomes x. Now, of course, plus c, but don't worry about that till then. So I'm going to leave myself some room. Let's come down here. We have uv ln x times x. I'm going to write the x first because ln x times x, I'd be tempted to make it x squared, but that's not the case. X times ln x minus v du. Okay, so v du is x times 1 over x. And I see this what messed me up, forgetting this dx, right? Okay, so we do have dx here. That's important. Otherwise, I don't really know what I'm integrating. Well, x times 1 over x is just 1. So we just have the integral of dx. As before, I said with the ex is right, that integral often comes up again. Here it is again. I have integral of dx, I know is just x. So just looking at this part alone, that becomes minus x and plus c, because I'm integrating, right? So we have x ln x minus x plus c. This oftentimes, as I said, a book will write as a formula. The integral of ln x dx is x ln x minus x plus c, but that is why it's the formula. Okay, integration by parts creates this formula. All right, one more example. Again, it's weird, but this is going to be the dv. Okay, so the dv is the dx. We know the integral of that is just x, as we just did. So therefore, u is ln x to the 4th. And remember, the derivative of ln is du over u. So du, the derivative of x to the 4th is 4x to the 3rd over x to the 4th dx. And if we simplify this, we just get 4 over x. Okay, so formula uv minus v du. So uv x, I'm going to again write it backwards, ln x to the 4th. I wrote vu minus v du. Okay, minus x times, let's use a simplified version, 4 over x dx. Those x's again cancel, so we just have the integral 4. And the integral 4 is just 4x plus c. Okay, and there we go. That is our result. I do want to show one quick trick. Okay, so let me go and rewrite this example again. For this problem in particular, because we talked about properties of logs, and using them or not, sometimes it cleans it up, sometimes not. The exponent can come down. Okay, x to the 4th with a natural log, I bring that 4 down, which means then it's just 4 times the integral of ln x. Right, but this I know from that first example here, so we get 4 multiplied by x ln x minus x, and then we do have a plus c. But then our answer looks slightly different. We have 4x ln x minus 4x plus, well, we have 4c, but 4 times some c is still just some constant, right? I don't know. So these are just slightly different, but using that property that the number out front being multiplied can go back to the exponent. I don't know why I have a negative. That was supposed to be an equal. Whoops. Okay. This 4 can go back to the exponent, in which case then we'd be right back to here. X times ln x to the 4th minus 4x plus c. So they are in fact the same. In fact, I mean, it'd be ugly, but we could move the x to the exponent as well, ln x to the 4x power, but I think this version looks cleaner.